Hi everyone, I welcome you to the presentation of this video under mechanics of machines, subject called simple gear trains. Okay, so sometimes two or more gears are made to mesh with each other to transmit power from one shaft to the other. Such a combination is what we are calling a gear train or train of toothed wheels. So these are the gears there in a combination which we are calling a simple train. Okay, so the nature of the train used depends upon the velocity ratio required and the relative position of the axis of the shaft. So a gear train may consist of a spar or spiral gears. Before I go any further, I would kindly ask you to subscribe to my channel. Just hit on the subscribe button, which is right there. Press it, and then if you subscribe, it will write subscribed, and then you can also click on the notification bell so that you get the latest videos which I make. Okay, let's proceed. So under simple gear train, so when there is only one gear on each shaft as shown below here, which is this one here, this one is what we are calling a simple gear train. So there are a number of gear trains, but a simple gear train is one where on a gear you only have one shaft. On the shaft there is just one gear. As you can see, this shaft there is just one gear there. This shaft there is one gear. That shaft there is one gear. So such a combination of gears is what we are calling a simple gear train. Okay, so when the distance between the two shafts is small, the two gears, gear 1 and gear 2, for example, this one and that one there, are made to mesh with each other. Okay, as you can see there, to transmit motion from one shaft to the other. Since gear 1 drives the gear 2, as you can see, this gear, we can call it gear 1. As it rotates, it's driving gear 2. Therefore, this gear 1, which is rotating gear 2, we are calling it the driver. And then the one which it's gear 1 is driving, we are calling it the follower or the driven. Okay, same applies this gear 2 and gear 3. For this one, gear 2 is the driver, then gear 3 is the follower or the driven. Though this one is an idle gear, you understand this later. So such a combination there, where this one is driving that one. The one which is driving the other is what we are calling the driver, and then the one which is being driven is the driven or the follower. Okay, so we have the general formula there, the general formula for the gear trains. So this general formula is this one. You multiply the speed of gear 1 times the teeth for gear 1. This should be equal to the speed of gear 2 times the teeth for gear 2. This should be the same as the speed of gear 3 times the teeth of gear 3, which are these. These are the three gears. If you have many, to just go on like that. So from this we can derive these two equations. We have this equation which we are calling the speed ratio. Speed ratio is basically speed 1 divided by speed 2, which is speed of gear 1 divided by speed of gear 2. This should be equal to the inverses of the teeth. So teeth of gear 2 divided by teeth of gear 1. If you do the reciprocal of that, you have a ratio which we are calling the train ratio. This one is the speed of gear 2, which is this one, divided by speed of gear 1. This should be equal to the teeth for gear 1 divided by teeth for gear 2. If you're relating these two gears, you consider this as gear 1 or that one gear 2. So for two consecutive gears, you have that. Or for the first one and the last one, these are the two equations derived just from that. So you can equate this and this, and then from this you can have the speed ratio, or you can equate this and that, or that and that. So for this we equated this and this, and then we are able to derive the speed ratio and the train ratio. Let's look at an example. So a simple gear train consists of the driving gear, intermediates, and the follower as shown, which is this one here. So you have the driving gear, which is this one. Then there are gears in between, which we are calling intermediates, and we've got a follower there at the end. So we get the values of x, y, and z, which have been given there from that table. So this table is showing the speed of gear 1. This is gear 1. The speed has been given to be 900 revs per minute. Then you've got gear 2. You've just been given the number of teeth. The speed hasn't been given. Gear 3, number of teeth. Speed is not there. Gear 4, number of teeth as well. We don't have the speed. So I want us to calculate the speeds for these gears, given that they have different number of teeth. Yeah, you can view them as having the same number of teeth, but this was just a GIF which I used, but the actual information is this one here. So let's try to calculate the speeds there. So on our solutions, this was the table which was given. We have for gear 1 you have that, gear 2 you have that, gear 3 as well as gear 4. That was the information which was given there. So from that data, which is that one, we have N1, T1, T2, T3 and T4. So we can look for the unknowns, which are these N2, N3 and N4, X, Y, Z. So from the formula there, if you're relating, so the first one has everything. It has the number of speed and the teeth. Then for the second one there, you only have number of teeth, but we don't have the speed, so you're going to have that. For the second one you have that, third one you have that. So from those we can now calculate what you're looking for. So for the first one, which is that one, we have everything. We have N1, which is 900 revs per minute. N2, the speed there hasn't been given, it's X. T2, number of teeth there is 25. T1, number of teeth is 15. You're going to have that. If you come to the second one, which is this one, so you have this one which has everything, which is this one there, it has the 900 as well as the 15. But if you look at the T2, T2 has, it's been given, it's 20, which is that one. N2, we don't know, it's the Y, which is the speed we are looking for, that one. Same applies for this one. You're just equating this guy to that one. So you're going to calculate the values for X, Y and Z. For all of them, if you're to do them at the same time, you're going to have X, making X the subject of the formula. You're going to have 540 revs per minute as the speed for this gear. Y, 675 revs per minute, which is the speed for that gear. And then Z will have that. So this gear will be rotating at that speed. Thanks for watching.